Perfect. There it is.
Great. Thank you, Patricia. Thank you for the introduction. Nice to meet you all. Looks like there's some very interesting work going on in ITI with a lot of overlaps actually with things that we're thinking of and doing at Glasgow. So I'm going to talk about some of the work that we're doing on haptics, particularly in the area of mental health. So we've got a few projects going on right now, which hopefully tie into some of the things that you guys are thinking about as well. So I'm from the School of Computing Science at University of Glasgow. But as Patricia mentioned, this is part of the Distinguished Speakers Programme made possible by the ACM. Thank you to them. And that's I think it's a great way to get speakers from all over the world talking to people in other places all over the world. So it's a really great program that the ACM do. So I'm very happy to be part of that. So I'm not sure what everyone's background is in the virtual room we're all in. But I thought we should start off by thinking about, well, what is human-computer interaction? So according to the ACM, which is this big organization for computing science, and SIGCHI, which is the part of that focuses on HCI, human-computer interaction is a discipline concerned with the design, evaluation, and implementation of interactive computing systems for human use and the major study of the major phenomena surrounding them. So it's all about humans interacting with technology in different ways. It can be different groups of people, different locations, different applications. So it's anything about how humans come into contact with technology. And that's quite broad. So my part of that is this idea of multimodal interaction. So here we're using all the senses that we have as humans, all those control capabilities that we have as humans to enrich the interaction with our devices. Most of the time, it involves me looking at a screen or maybe using my fingers to type or tap. But most of my other senses are not really heavily involved. So part of multimodal interaction is thinking that how can we use all these capabilities that we've got as humans? So this is, of course, a more human way to be, because when we're in the world, we use all of our senses and control capabilities all the time. It might be that you're designing for people who don't have all their senses. So, for example, someone with a visual disability needs an alternative to the screen because maybe that's not very effective for them. So how might you use another modality to replace that? Or it may be that your capabilities are not available all the time. So, for example, if it's the winter, you're wearing thick gloves, then using your touchscreen phone becomes a whole lot more difficult. So in some ways, you become more similar to a person with a motor disability. So how can we design around that? And the way we do that in everyday life is that no one sense does everything. We use all of our senses, all of our capabilities together. And that's what we're really all about in multimodal interaction. So trying to design new ways of using technology, using multiple senses, using multiple control capabilities to give as rich an interaction as possible. So the kind of things we do mostly are audio-based things, non-speech audio-based things. We do a lot of haptics, which is what I'm going to talk about today. I'm just going to talk about one slice through the haptics, but we do all sorts of different kind of things with haptics. Been doing that for a long time. Gestural interaction, and then things like smell-based interaction, and we apply them in lots of different settings. Very related to what Patricia mentioned in the introduction, we have a big lot of work going on at Glasgow around AR and VR or extended reality. I have a big project about how you might use AR and VR for passengers when they're on the move. We're doing things in cars, inside cars for drivers, using augmented reality. We're doing audio augmented reality, so not having a visual display at all, but using 3D sound. And then lots of applications around health and accessibility, and also one about care robots, which I'll talk a little bit more about today as well. So for today, I'm going to give a brief introduction to haptics. I could easily give a whole course on that as I do to our undergraduates, but we'll have a very brief introduction to haptics. Then I'm going to give you some examples from our work about how we've been using haptics, particularly for stress and stress reduction. And there's three kind of broad parts to that. There's something about vibrotactile haptics, and how we've been using that for social anxiety, people suffering from social anxiety. Then about care robots and how you might use care robots to reduce stress. And a nice study that we recently did, kind of in the wild evaluation with some of our students. Look at how we might use vibrotactile haptics there. And then a kind of new area of thermal haptics, so how you might use your ability to perceive temperature and how you might use that, that kind of untapped area of haptics to make more lifelike kind of care robots. So haptics, what's that all about then? There's two kind of broad parts to haptics. So in general, it's the sense and or motor activity based in the skin, muscles, joints, and tendons. So anything you can feel through your skin, you can feel through pushing or pulling, all those things come under the haptics sense. So it's actually pretty broad. And within it, there's really kind of two main parts. The first one is kinesthesia or kinesthetic haptics. And that really focuses on the sense of motor activity, force, things that you can perceive through your muscles and tendons. So if you're pushing against something, pulling against something, twisting things, that's all in the kinesthetic part. And then there's the cutaneous part. This is the stuff that you experience through your skin. So if you imagine holding your smartphone, you feel that vibration that comes through your skin. So this is based around skin, and that's what we're going to talk about mostly today. So there is an ISO standard about tactile and haptics, 9241-910. So that's that kind of like lays out the area of haptics. They describe haptics in this kind of structure here. So we have these two parts, this kind of cutaneous part through the skin and the kinesthetic part through the forces and the movements. And then within that, they break down into smaller parts. So we're today going to focus on the left-hand branch of this tree, and then mostly on the mechanical part and the temperature part. But as I mentioned, haptics is a very large topic, and we've done things in some of these other boxes as well. So there's lots that haptics has to offer, and many of these boxes are not really well researched. So there's lots of interesting research questions right here. So yeah, we're looking at this part down the left-hand side, and we'll start off looking at this tactile feedback here from mechanical stimulation, most often called vibrotactile haptics. This is the one that we're most commonly see in our everyday lives. So as I mentioned, this is perceived through the skin. So there's some kind of vibration motor that might be in your phone or something like that. It kind of shakes around and you can feel that through your skin. In your skin, across your whole body, you have these things called mechanoreceptors. There's all different types of these. They do different kinds of jobs, detecting high frequency, low frequency, stronger forces, weaker forces. There are different depths and different densities across your body. So for example, your hands are very sensitive, but your back is much less sensitive. That's important to think about from a design perspective as to what kind of device that you're making. If you're making things that go on your hands like gloves, you can rely on very high sensitivity. If you're making something like a belt that went around your waist, then you're going to have much lower sensitivity. The most common use of vibrotactile haptics is for alerts and messages and things like that. You know, we experience those all the day, every day on our phones. And there's a design language for these. It's called tactons, which allows you to design these tactile icons by creating different kind of tactile messages. There's lots of work been done by us and others on this kind of tactile language, which can help in design. And you can see these things used in different kind of applications in everyday life. You know, if you're using a games controller, you can feel the vibration as your car drives off the road, or as you shoot, and you can feel the recoil of your gun. You might have it in your smartwatch so that you can feel messages delivered to your wrist, or of course in your phone. But in some ways, it's a little bit boring. We've been doing that now for quite a long time, and I'd like to kind of persuade you today that there's more to haptics than just vibration and alerts. That's our everyday experience of them right now, but there's a whole lot more that haptics can offer. And one of the most interesting things is this area called affective haptics. So this is a new kind of topic emerging in the area of haptics. So this is around the study and design of devices and systems that elicit, enhance, or influence the emotional state of the human by the sense of touch. So affective in this case means emotional. So this is using haptics to change the emotional state of the person experiencing it. So this is not just a vibration telling you that you've got a message. This is using affective haptics to manipulate your emotional state. So I'll give some examples of 3 projects we've done in this kind of area, which I think show some of the interesting possibilities of haptics that haven't really been touched on very much yet. So first one is looking at comfort objects for social anxiety. So social anxiety, this is the fear of negative evaluation during social performance. One of the most prevalent mental health conditions in Western countries, this social anxiety disorder has a lifetime prevalence of 12%. So huge number of people get social anxiety disorder. Has many negative consequences on your life, maybe even leading to you unable to go out of your home, be able to make social connections with other people, has many negative, and then that consequences lead to physical consequences as well. So many problems caused by this idea of social anxiety. So what we were thinking about is, could we design a discrete emotion regulation device that you could use during social exposure, which might be, giving a presentation like this, which is, a stress-inducing activity, or just meeting people in a social setting. So could we design a device that you could take with you and use that would help reduce your stress and anxiety? So our design process for this was starting off talking to people who suffered from social anxiety, to try and see how we could make something that would suit their needs. So we started off really with our users, trying to understand what our users wanted. So we did a kind of participatory prototyping activity first, where we got people to design objects that they could imagine holding in these socially stress-inducing settings that could help reduce their anxiety. So we gave them all sorts of interesting things. There's Lego bricks and different types of materials and Play-Doh and glue and tape and all sorts of different things for them to try and design some simple objects that they could imagine carrying with them and using in these situations. So that means they could use them every day whenever they were. And within these, we used this idea of emotionally resonant vibrotactile cues. So this is haptic feedback designed to evoke some real-world emotional experience. So we base these around pleasant, but it could also be unpleasant experiences from the real world. So a classic example might be a heartbeat. So you could feel a heartbeat through a vibration cue, and that heartbeat you then might perceive as calming. It might be, that you were feeling the heartbeat of a loved one close to you, or even a heartbeat of a pet if it was sat with you. Another one, cat purring. You could feel that cat purr as a vibration experience. Things like water bubbling, waves, breathing, rain. There's a lot of these things that have a haptic experience to them that can create a calming experience. So these cues are resonant of emotional experiences in other parts of your life. So we got people to design these objects. They came up with many interesting designs. Here's a few of them. We kind of classified them into 5 different groups. So people kind of generally made things that fell into these different groups. So kind of round things that people could hold in their hands. You can see several of these have kind of got furry exteriors. That's maybe like holding some kind of small animal or something like that. People made models of things. You can see one that looks like a person there, one that looks like a flower. Things with finger grooves in them so that you could hold them quite nicely and discreetly, but they felt firm in your hand. And wearable things, so people there made a kind of bracelet. And then there were some kind of square things which had a square shape in your hand. So of all the things that they they made. We kind of categorized them into these different categories, and then picked out kind of 4 key examples from all of those, which had different types of materials, different shapes, that kind of captured something about all those different things that they'd designed. So you can see 4 of them there. One of them is this kind of Lego shape, a squarish shape. One is a kind of round, softer, furry shape, one with hand grips, and one which was a kind of model. So we have those. Then for each of those, we cut a hole inside so that we could then insert a vibration motor. You can see the vibration motor on the kind of right-hand side, on the control board anyway, on the right-hand side in the background there. So we inserted a vibration motor inside the shape. So we didn't change the shape, but it had a vibration motor inside. And then participants chose their most favorite emotionally resonant cue to go in the object. So, for example, if it was a furry object, some people chose purring because maybe it's a little bit like a cat. For some of the objects, people chose a heartbeat because it was something that kind of felt like it was alive or breathing. So people could choose their favorite ones to go inside this object. So then we wanted to see, well, these objects, do they actually help people to be more calm and relaxed in social settings? So we ran a study. So what we did was a small version of what we're doing right now. We got our participants to give a Zoom presentation to 2 other people that they didn't know. So a kind of stress-inducing situation. These were people who had social anxiety. So this is a stress-inducing situation for them. And they did it both 2 groups. So one group did it with the comfort object that they designed, and one did it without any kind of comfort object. We measured a whole load of different things, typical things like skin conductance and heart rate, which are physiological measures of stress. We also looked at lots of qualitative measures of stress, anxiety. For example, STAI is a standard psychological measure of stress. As a kind of qualitative questionnaire, post-test interviews. So we took a whole load of measures of stress before, during, and after they'd given this presentation. And the results were quite positive, really. So the comfort objects did reduce stress, for example, as measured by this state trait anxiety inventory, which is a standardized stress measure from psychology, and heart rate for some participants. Not all participants benefited from that. Some people were still rather stressed, but some people you could see physiological improvements. In the interviews that we did afterwards, many people thought that the objects were calming to them, even if it didn't necessarily show in some of their physiological data. Physiological data is notoriously difficult to really see strong results in. 68% thought that the vibration helped the object rather than just a plain object, so they liked this emotional resonance, the object from the object. And 79 said that this would help them in anxious situations and they would like to use it. So the results were pretty positive, that something discreet and simple that maybe you could hold in your hand or you could wear or something like that, that nobody else would need to see, that would help you in these socially anxious situations. And that could then allow people to give presentations, meet people, go outside, get involved in social settings and social situations, which are known to improve mental health anyway, by using this simple and discreet device. So we were happy with those kind of results, and then we're trying to think, well, where could we go further from this in order to try and use these in other settings? And one area of interest is with care robots. So there's lots of discussion of care robots in the media and other areas like that. That we may need care robots in the future to look after people. Many times care robots are mostly aimed at older people or people with more severe disabilities. And what we were trying to do is, could we help different type of demographic. And our demographic, being in a university, we were kind of interested in seeing what we could do with students. Student stress is a very common thing. I'm sure across the world, students get stressed during exams. Now students are all working. They have stressful lives as well. Many students drop out or underperform due to stress. And I don't know about universities in Spain, but certainly in many in the UK, even in my kids' school, but this is an example from the university here, animal therapy is often used, where they bring in some nice doggies to the school, and people can pet them, and this is a well-known activity for reducing stress. But it's expensive. It induces stress in the animals, so that's not necessarily good. They're not available all the time. This is only a very specialist activity. So we wanted to see, well, could we have a care robot that would help with student stress that they could have access to more often, for example? So these things, as I said, have been tried with older people, but not really with young adults. So we wanted to see if we could find some effective use here for young adults and students. So we used a zoomorphic robot, which I'll show you in a minute. So we did an in the wild study in our university library. So we took 22 students who studied in our university library, and we tested them, or we did our experiment in the library, in the study space. So this was completely in the wild. We didn't take them to a lab. We did it in the library where they normally were. So we had them over 6 sessions, and they did 3 sessions with our robot and 3 sessions with their phone. And on the phone, they just did what they normally do with their phone, which these days is mostly browsing social media. So this is the robot that we used. It's called a Paro. I'm not sure if you've seen this one before. So this is a standard robot, commercially available. It moves in response to touch. It's quite heavy. It's got a nice furry texture. It blinks its eyes and looks at you. It gives you a very strong haptic experience when you're holding it. It feels like, in many ways, like holding an animal. It has the kind of weight of holding a cat or a dog or something like that. I'll show you a little bit of video of the experiment that we did. So here you can see this is just a space in the library that we used. There's the robot. This is the bit I wanted to get to, just to show you the robot. It's quite cute. It looks at you, blinks its eyes. You see it's wagging its tail, or flippers, or whatever seal has. You get the idea. So the students used the phone for 3 sessions, or the seal for 3 sessions, and the seal. They did both. So they used both. With the phone, we just let them use whatever they wanted to on the phone. It's up to them, just what they would normally do in a study break. And then with the Paro seal, they could do what they wanted with it. So most people kind of hugged it on their lap, or stroked it, or played with it. We didn't tell them what to do. It was up to them. They could do what they wanted with it. You've seen that. So we collected, again, a whole load of different results, quantitative and qualitative results about their experience. Unfortunately, the labels on these graphs are insanely small, but I'll tell you what they show. So the kind of orangey bars are the paro, and the purple bar is the phone. So the first graph on the left, that's their anxiety score, and you can see that over the sessions, anxiety dropped significantly. The middle one shows a stress score. Again, stress dropped significantly. And the one on the right shows their mindfulness score, and the mindfulness rose significantly over using their phone. We did a whole detailed qualitative analysis, which I haven't really got time to tell you about now, after interviews. So we extracted a lot of information from them. But really, Paro significantly reduced all the measures we took of stress. We took a whole lot of measures, including these ones. We did it over 3 sessions because there's a danger if you just do it over one session that there's a high novelty effect. Nobody's seen one of these kind of robots before. The first time you use it, it's crazy, it's amazing, but that's not how it would be over time. So we tested them over 3 times just to see how it would be. And actually, we found that the effect actually improved over time. The first time there was a kind of novelty effect, but over time, they actually benefited more. And one interesting thing was that actually the phone was really not an effective measure of stress reduction at all. From our qualitative discussions with the students, they often found that using social media made them feel more stressed after their study break than less stressed. So the Paro really made a big difference here. Being able to use it, it really people were talking about it as a kind of pet. It really had many of the benefits of the dog therapy, but now it would be available all the time. You could imagine the library might have a robot there that the student could borrow, or they could go into the booth where the robot was and play with it as a way of just reducing their stress during study breaks. I think this nice in the wild study that we did in the library really showed that it works in a very practical context, not just in the lab, but outside the lab. So the next stage was to add a bit more active haptic feedback to it. So that robot, it does move and you can feel it moving. So it does have haptic aspects. You can feel its fur. But we wanted to think, well, what could we do with something more active? So here then we used the vibration motor. This is the same vibration motor that was in the comfort objects. We put 2 of them into the Paro. You can see this, the control board at the top there from this picture, and then designed a heartbeat, which is basically the same heartbeat that we had from the emotionally resonant set of feelings from the previous experiment. So we then put those into the Paro. So this time we did a lab study to see what it would be like in the lab. So to try something different, we got 30 participants to watch horror movies, in this case to induce stress. If you want to know, there is a kind of categorized set of horror movies out there. So we knew that we were taking movies which were all horrifying. So we used the movie The Shining, Misery, and Blair Witch Project, if you're familiar with those. All have fairly terrifying bits in them. And then we compared people using the Paro with and without the heartbeat. So this is a regular Paro, then the Paro with the heartbeat. And we measured them before, during, and after the exposure to these horror movies. And we've again found a significant reduction in stress with the Paro, but an even larger reduction in stress when the Paro had a heartbeat. So the heartbeat added to the stress reduction of Paro itself. And the key thing that came up with our qualitative analysis of what the students were talking about is this idea of attentional redirection. So in the scary bits of the movie, when nasty things are happening and the door is being chopped down by the axe in The Shining, you can redirect your attention to the comforting feeling of the robot, and particularly with the heartbeat. So it made it feel more lifelike, made it feel more alive than just the robot itself. Even the robot moves, but adding a heartbeat made it feel more lifelike. You would probably feel the heartbeat of your pet if you were holding it, or certainly if you were holding on to a loved one because it was a scary part in the movie. So it reinforced its physical and social presence when there was this additional heartbeat there, made it feel more alive. So the addition of the haptic feedback here added something on top of what was there through the existing robot. So again, shows that with a very simple addition, adding a vibration motor is a very common thing. We have them in our watches, games controllers, phones. So adding a vibration motor would not be a complex thing to do to a device like the Paro robot, but you can have a significant improvement in its performance. And then we wanted to see where we could go after that in a slightly different area of haptics. So thermal haptics, very understudied. So lots less work in thermal haptics than there is in vibration, for example. So if we think back to our diagram of the structure of haptics, so we're now thinking about this part. So you still perceive thermal through the skin, of course, but this is not vibration. You have a different set of receptors in your skin for thermal, again, differently distributed across your body. Some parts of your body are more sensitive, other parts are less sensitive. But yeah, there's much less research in this kind of area. But if you think about it, it's always present. If ever I have a kind of bare skin interaction with something else, I always feel temperature. So if I shake hands with somebody, I feel the temperature of their hand. If I hold onto my cup of tea, I can feel the temperature of it. So anytime I have an interaction with the world, I feel temperature. Humans are very sensitive to it. Sometimes I even use it to understand things that I can't see. If I look at my teacup, I can't tell if my tea's gone cold or not, but I can certainly tell if I touch it. So it can tell me additional things about the world that than just my visual experience. So an interesting question is, can we use that for communication? So if you think about temperature, there's a very strong emotional response to it. If you touch something that's cold and you expect it to be warm, that can be quite surprising. It's even embedded into language, because you might say something like warm and loving, or oh, he's very cold. The kind of emotional aspects of the temperature are even embedded in language. As I mentioned, it's also used for other things, so like determining material properties. You might look at a desk, and if the desk is made of material, it could be wood, or it could just be metal painted like wood, but you touch it, okay, it's warm, that must be real wood, or it's cold, it's probably metal. And of course, yeah, there's the children's game where you tell them they're getting hotter or colder as they get closer to the present that you've hidden for them. So it's used a lot in our kind of lives, but very little in devices that we create. So maybe it's some kind of alternative to vibration. Maybe it can do things that vibration can't do. It's not particularly complex to do it. We use these things called Peltier heat pumps. This is a standard electronics component. The interesting thing about the Peltier heat pump is that one side heats and one side cools. So oftentimes it's very easy to generate heat. You pass energy through a copper wire, it'll heat up. But it's actually quite hard to cool things down. So the Peltier is nice because depending on which way up you have it, you can do heating or cooling. So it's a standard component, low cost, relatively easy to use for somebody who's not a hardware guy like me. So we built various different devices. We built one with 4 heat pumps on it. So you can have 2 pairs of hot and cold. It runs off a battery, so you can have it as mobile if you want to, or you can have it as plugged into the mains power. And over the years, we've run different psychophysical studies to investigate the ranges of temperatures that can be used, looked at mobile effects, kind of seeing how people use it in the real world. So we thought we would then, actually, here's a picture of one of the ones that we designed. We thought maybe it would be interesting to try and use this with the robot to see if we could enhance the feeling of it. If you were holding a pet or or hugging another person, temperature is a key part of that. You know, my dog is very warm. When she's sat on my lap, she's very warm, and I can feel that. So could we use this temperature aspect as something? So would thermal feedback be comforting? And then what temperature would people want it to be set at? It's not even clear what the right kind of temperature would be. You don't want it too hot because you don't want to burn people. And if it's very cold, that might be uncomfortable. So we wanted to try and find out whether temperature would be comforting and what kind of temperature would be appropriate. So we added these Peltier elements to the Paro. You can see in the red square on the Paro's back there, where you put your hands on it, we had these two heating elements. In this case, not super well integrated. We might be able to do a better job of that in the future, but sufficiently there that you could feel the robot doing its normal robot things and then add temperature on top. So we had 45 participants, and we split them into 3 groups. One group didn't use the Paro, one group used the Paro, and then one group number 3 used the Paro with our thermal feedback. So this time we used a stress test called Mannheim multi-component stress test. This is a very standardized test to induce stress in psychology. Again, different one to the previous 2. It's nice, I think, to use different types of stress induction tasks just to get an idea across a broader range of types of stress, whether this kind of affective feedback works. So yes, this is a standard one from psychology. You have all sorts of different things in there. There's motivational stress through financial incentive. So you offer them some money and then you can decrease the amount of money that you give them depending on how well they do. There's emotional stress. So it includes a set of graphic images, which are quite disturbing. Has auditory stress. So you play white noise in the background, which gets louder. And you have cognitive stress. So you do some kind of maths task or some other kind of cognitive task that adds stress. So all the participants went through this, but one group, before they started, they got access to the Paro, and then we asked them to set the temperature of the Paro to what they thought was comfortable and calming. So they could change with a controller. They could change the temperature of the Paro until it felt kind of comforting and calming, and then they used that temperature when performing this stress test. So participants found the Paro comforting and helpful in reducing stress, but actually they felt calmer with the Paro and the thermal feedback. So the thermal feedback added more calming than just the Paro itself. And in the end, because we gave all people a chance to experience it, 73% said that they felt calmer with the Paro when the thermal feedback was added to it. So that the temperature added something. Again, it was this idea of attentional redirection. So one of the participants said, the warm sensation was calming, gave me something to focus on. So it added something, that kind of warmth, that warm sensation added something. Some people found it more distracting. Now you could say that was a good thing because it kind of helped distract them from some of these this stressful task, but some people felt that it could be distracting. But also many felt that the thermal made the Paro feel more lifelike. So one person said, yeah, the heat, it made it feel more like a cat, which I find extra comforting. This idea of it becomes more like a pet that you're holding on your lap rather than just a robot. In some of the studies, people did mention that, yeah, it feels robotic because when it moves, you can kind of feel the motors and things inside it, and that breaks the kind of feeling of it being a pet or an animal. But adding these extra things in can reduce some of that and makes it feel more lifelike, overcoming some of that kind of mechanical, the motors and the components inside it that help it move. So it becomes then more comforting. An interesting question was, well, what temperature would people choose? So we recorded all the temperatures that people chose. And here's the distribution. So you can see that the temperatures are laid out there on the x-axis. And most people were choosing in the range of 30 to 34, with the most at 32, which is not surprising. Generally, your skin sits at about 30 degrees. Your body tries to maintain about 30 degrees skin temperature, so that whatever environment you're in, your skin sweats or heats up to kind of maintain about 30 degrees. So something at 32 to 34 degrees is just a bit warmer than your normal skin temperature, so you can feel it being warm. People didn't really go higher than 36. If you go too high, then it starts to feel too hot. So at 40 degrees, it starts to feel quite uncomfortable. So people were generally in that kind of range of skin temperature. But there was a few interesting people who were not in that range. So our lowest participant wanted a 4 degrees. 4 degrees is pretty cold. Now that person, when we asked them about it, they said that well, they kind of complained that they always had hot hands, and they actually liked the robot to cool down because it helped cool their hands down. So this is interesting, because then it seems like perhaps personalization would be important here. Maybe you can't just set the robot to be 32 degrees, because that would be that's the most frequently occurring value. Maybe you would have to allow some personalization so you could control it. That may potentially also be the case depending on the environment that you were using the robot in. So we were using the robot in the UK in a lab in the university, where it was a typical indoor temperature of mid to late 20s centigrade. But if you're using this in a very hot environment or a very cold environment, you may also want to change the temperature of the device. So it seems like personalization is a key thing here. For the vibration, people personalized it in terms of the type of vibration they wanted, in terms of this emotional resonance. And in the thermal, it seems like being able to set the range of temperature you choose would keep people happiest. So let's think about a few conclusions from all of this. So I started off with a little introduction to what haptics was, and this cutaneous part of haptics that you perceive through your skin this is a super rich sense that we have, very powerful sense that we use for manipulating objects and feeling objects and exploring objects in the real world. It's really very underused in most user interfaces. The thing we mostly get now is a vibration from our phone, or a vibration from from our smartwatch or something like that. And that's very limited in terms of what human sense of touch is capable of. I don't know what the equivalent in vision, but maybe a small black and white screen or something like that, compared to a large 3D full color display. So I introduced this idea of affective haptics. So this is a new area of study within haptics, and looks at how you can use touch to change the emotional experience or the affective experience. If we think of our everyday lives, touch is really key for that. If I shake someone's hands, I hug someone, I hold my pet, all of those things give me kind of emotional experiences. So how can I bring that to technology? I don't want my technology to be something kind of old and dead. I want it to be something warm and lively and interesting. So this gives us new possibilities for the use of haptics. We can do new things with it. So we have 3 different examples. The first one was for social anxiety and helping people with social anxiety, trying to make something that they could use in a discrete way that they could wear or hold, which would help them reduce anxiety. So here we use these emotionally resonant cues that remind you of something pleasant from the rest of your life, presented through in this case vibration, and then they design these haptic comfort objects that they felt comforting to hold, and then tried this experiment where they had to do a Zoom call to 2 people they didn't know, which is quite a stressful task, and found that it did have a positive experience there. Then we looked at the social robot, this social robot. People had used it in care settings for older people, for example, but it hadn't really been looked at to see if it could do something with students. So we tested it in the wild to see if we could do something for students studying, which is a highly stressful activity. We tested this at exam time at the university. So it's a highly stressful time for the students to see if we could do something. The university brings in these comfort animals, but that's expensive. The students don't get access to them, and it can be stressful for the animal. The robot, that could help resolve many of those issues because it could be available all the time. And we really saw a positive effect there. And as well as doing the lab studies, we also did studies in the wild studies. We also did more controlled studies in the lab. Then we looked at adding a heartbeat and thermal feedback. Both of those added significantly to just the robot on its own. Both of them made the robot feel more lifelike, more comforting, allowed this idea of attention redirection, so away from the scary movie to the robot, which is exactly what you would be like if you were holding your pet on your lap whilst you're watching that scary movie, or squeezing the hand of a loved one as you're watching that scary movie. So these really allow us to tap into the emotional experiences that we get from hugging animals, other people. So we're not just giving vibration feedback to tell you got a message. We're really now tapping into something highly emotional and kind of getting into the human aspects of the sense of touch there. So I really think, just to finish off, that affective haptics is a really untapped area for interaction. This is a great way to try and influence people's mental health and well-being by creating stress-reducing applications, allowing them to tap into other experiences from their lives. And this opens up a whole new range of design possibilities. Most of these things are really just research prototypes that we and others have done in the labs. Very few of these have come into real products as yet, but there's a huge amount of possibility here, I think, for affective haptics in real products. And with that, I will finish. I'll stop sharing my screen. And then I'm very happy to have any questions if anybody's got anything they wanted to ask.
So thank you very much. That was an amazing talk, and it really resonated with the work we are currently doing. So we got a lot of insights. And if people want to ask a question, you can unmute yourselves directly or either write in the chat, whatever you prefer.
Yeah, hi, I'm Vicente, and I have a question particularly regarding hardware, as my background is around electronics and so.
Yeah.
So you mentioned you used a Peltier cell and for generating temperature changes on the Paro robot. So in fact, in industrial engineering master's thesis, I used one Peltier cell to regulate the temperature inside of a cage to provide an adequate environment for like it's called C. elegans, which is a common species worm for genetic studies. So for the effectiveness of the system, I had to mount heat sinks with fans on both sides of the Peltier cell, because if you don't evacuate the heat away from the surface, the hot surface will drag or dominate the cold one. So yeah. Therefore, I would want to ask, how did you manage to generate this cold output as low as 4 degrees, I think, and if it was or not a sustained temperature over time?
I'll see if I can just share this. Oh, I won't share the slide. Well, yeah, I've got on one of the slides I showed my Peltiers. You could almost see there were heat sinks in the back. You are right. That is the kind of downside of the Peltiers, is that, yeah, you need to get, for cooling, you need to get rid of the heat on the other side.
Yeah.
For the robot case, discharging the heat into the robot seemed to work okay. It's quite big, so it wasn't warming up the other side of the robot when you did cooling on top. So it wasn't such a problem in this case. But in some of the other experiments where we've used these devices, yeah, you have to have heat sinks on the back, and it makes the design quite complicated and ugly. So it is slightly problematic. My answer to this is, look, I'm not a hardware guy, I'm a software guy. You and other clever hardware guys, you should sort that out.
No.
So I can show it's possible, but I can't show an elegant design for it. But you know, there are certainly, if you only want to do heating, it's much easier, because then you don't need you don't need a Peltier. You can do it with other much simpler methods. But although our results suggest that you may need cooling, so I think then it becomes an engineering problem, which a computer scientist like me is not equipped to solve that kind of problem. I'll hand that over to someone else.
No. It's that's perfect. If you don't need more complicated stuff, it's better. Thank you very much for your reply.
Thanks.
Any more questions?
Hi. Yeah, if I may follow up on that question. Well, first, thank you, Stephen, for your presentation. It was very insightful. Yeah, following up on that, I think Patricia mentioned our project, ARCADIA, and the fact that we have a emotional avatar or emotional companion that follows the user through the mixed reality experience. One of the next steps we are right now taking it and designing is to externalize and physicalize this avatar, so the user can 3D print it, put some electronics inside, and carry it with them in their everyday life or whenever they have that.
Nice, yeah, nice.
Challenging situation.
Oh, that's really similar to the thing I was talking about as well.
Exactly.
That's super nice.
So yeah, regarding the emotionally resonant cues, because we also wanted to follow up on something like that, I was wondering if you also thought, well, I guess you did, thought about adding some thermal feedback on that, on these small prototypes, especially because the heartbeat or the purring, they are very organic cues. And yeah, about the challenge regarding the Peltier pumps, how can we add something in a smaller factor and simpler for realizing this thermal feedback?
Yeah, I mean, again, it's just like the last question, that I think if you designed it carefully, so the way they held it, if you could have the heat sink, at the bottom where they're not holding it, then that would maybe allow the heat to dissipate away from their hands, so they're not holding it, for example. If you only wanted it to warm, then again, that's much easier, because you could just wind some copper wire around it and then heat it up like that. Although it could be hard to control that. The nice thing about the Peltier is you can, with a little bit of control, you can say, I want it 32, it's 32. Whereas if you're just heating a wire, it's generally, a bit less under control. So I think if you designed it carefully, yeah, you could. How much heating and cooling do you actually need? So you can get Peltiers of different sizes. So for example, you can get a 1 by 1 centimeter Peltier, which is kind of fingertip size. So if you knew where the fingertips were going to be, maybe then you could have that. You would maybe need less cooling because the Peltier is not so large. So we've used 1 by 1 and 2 by 2 centimeter size ones. So I think with some clever design, you could probably get around some of those issues.
Yeah, thank you for your insights.
And I think we have a question on the chat from Jose Luis, who is also from the HCI team. So thanks for your amazing speech. I would love having your opinion about the dilemma between using, especially on XR, natural interfaces like gestures versus using controllers with haptic feedback, focusing on presence.
Yeah, that's a great question. So we've done both. We do some of our AR and VR with bare hands, and we do some with controllers. So, I mean, I think the controllers are really clunky and poor interaction. I mean, they do give you some haptic feedback, but the interaction is pretty poor. People have tried to make gloves, although I've never really tried a super convincing glove that didn't come with many other drawbacks. For the freehand interaction, so I don't know if you've come across ultrasound haptics. So we had a big project on ultrasound haptics, where you use ultrasound to beam haptic forces to your hands. There's a company in the UK called Ultraleap who make a device who we worked with. So for hands anyway, then you could be doing interactions and feeling haptic feedback on your hands. It's not super strong haptic feedback, but you can do that, and it does allow you to have your hands free. So you can have the device in front of you, pointed towards you. You could have device mounted on your chest, so you could do things like this. Again, it's not perfect. I think really this is an open area for research. Nobody's got a good solution to this. And lots of people are working on input devices for VR and XR and AR, but there's no real good solution at the moment. So I haven't got a great solution I can offer you, but I can agree with you that it's a difficult question, and it limits a lot of things that you might want to do. One thing that we had a paper on last year was using this idea of passive haptics. I don't know if you've come across that, where you use, if you're in VR, you can use the physical surfaces around you. So in our case, we were doing VR for plane passengers. So then you could reach out and touch the plane seat in front of you. Now in VR, you can't see the plane seat in front of you, but if you align a virtual object with the back of the plane seat, when you touch it, it feels like you're touching a totally solid object. Or we also used the tray table, so that when you touch the tray table, it was aligned with a 3D object, so it felt like you were touching something solid. That works in a very narrow set of circumstances. You can do something very convincing with that, because I can't push through the tray table because it's strong, so it gives me a very strong feeling of haptics, and I could drag across it and things like that. But again, it's not fully free movement. It only works with particular things lined up in particular places. So yeah, it's a problem. Hopefully, research will come up with some solutions over time. But I've not got a good one for you.
So, any other question? I would like to ask a question, quick one myself. Now that we have the opportunity.
You're the boss. You could ask, Patricia.
Oh no, I wish I was. No, you're the boss here. So it was very interesting to hear you directly talk about Paro, because we are working with an animal therapy entity here in Valencia that work with animals, and they were very reluctant, like years ago, when they were seeing these social robots. That how could a robot make people feel in the same way as an animal? But then they saw your work, and they specifically mentioned the Paro robot, and they were amazed by how it really induced for especially for elderly people with dementia, that it was the same feeling as having a real animal for them.
Yeah.
So yeah, we were hoping to do this comparison between a physical entity as the tangible avatar that Samuel mentioned, the purely virtual experience with VR, in which you could touch like a digital animal, and then having this physical therapy with the real animal. So do you have any insights, or have you done any comparison with real therapy animals and this social?
Yeah, we just couldn't do that. It was just too difficult to be able to do a comparison to a real animal. For this, in this case, we were doing it. So I think that would be the $1 million question. Really, is it as good as a real animal? What I can say is that we found very positive benefits, and when we did that, that was just a basic Paro. At that point we didn't add vibration or thermal. So based on the other results, I would believe that adding those extra feedback types would make it even more engaging. But I can't say whether it's better than a real animal. But yeah, real animal is expensive. It has some downsides for the animals themselves. So I think potentially it has some really great opportunities. So I think doing the comparison would be super good. I was just going to say one thing that the student, or he's now a postdoc, who worked on the comfort objects. What he did was, for his next project, he took a very simple robot, but people were wearing AR glasses, and he projected on the robot, on top of the robot model, with different types of visual things. So you could make it look more animal-like, make it wag a tail, do different kind of things. So his next project was interesting because you could use a much simpler robot, but then add some of those affective features to it as well, because a Paro is quite expensive. So maybe combining a simpler robot and AR could get you a bit closer to what the Paro does, but for much lower price. And also gives other flexibility, because then it doesn't have to be a seal. It could be a cat, a dog, or whatever you prefer as your own choice. So I think there's potential for combining AR and the robots as well in kind of real life.
Yeah, that's really interesting. Thank you. So I think we're out of time. So yeah, we don't want to take any more time from you. Thank you very, very much for your time today and for your talk. It has been an amazing talk for us and really, really inspiring. I hope everybody enjoyed as well. And the recordings, as I mentioned, will be sent to participants and also placed on the YouTube channel if you want to review the talk. Thank you very much, everybody, for your time today, and especially thank you, Professor Brewster, for your time.
Yeah,
and
thank you for inviting me.
Continue speaking in the future. So,
maybe sounds like we should have some collaborations. We're doing some very similar kind of things.
Similar things, yeah, definitely. We should talk. So thank you very much for your time.
Happy Christmas, everyone.
You too.
Bye-bye.
Thank you very much.